Okay, cool. So let's work out a few of these. Um, what for me is very important in the probabilities is last time we looked at a, a table where they gave you the probabilities already. So tonight we're gonna go through a few where they give you the numbers again. So that you can just see how to use both of them. Let's quickly get okay. So in this question, and you guys can also see what they like to ask again. They ask us if events are independent or not. They ask us if something is mutually exclusive. So the first thing I would do is to say, okay, I know what mutually exclusive means. So let's first look at those two. Okay, so is events UK and female mutually exclusive? If it was mutually exclusive, that 143 should have been 0. Because if it's mutually exclusive, you can't, the definition says you can't be UK and female at the same time. So for this one, it is definitely the incorrect option. Unfortunately, we're looking for the correct option. Okay, then let's look at the second one on mutually exclusive. The events male and female are not mutually exclusive. Okay, so in this instance, where you would now see the total adds up to a 580. So there is not a third column to say that you're in both. The other way it could have been that you are in both is if the numbers are higher. So again, it doesn't happen. So events female and male are not mutually exclusive is also incorrect because they are mutually exclusive. Okay, because in this instance, there is nobody that's female that's also male. Otherwise, those numbers would not have added up to a 580. The same would have been if we said events Australia and New Zealand are, are not mutually exclusive because, again, you can't live in both countries at the same time. So I think it was always easy when we said between male and female, there can't be anything else. Obviously not anymore. But think of it with, you can't be physically, it's very difficult to be in two countries at the same time. So the countries is also going to be all three of them mutually exclusive from one another. Okay, but they haven't asked us about that. Okay, then if we need to look for independence, remember independence is the probability of a 1 times the probability of the second one must be equal to the probability of A and B. Okay, so remember that is when events are independent. So let's see if events AU living in Australia So the probability of this one is 102 over 580. Probability of female is 260 over 580. And that answer, let's quickly check. 102. Get it out right. 0.079 if I round it off. So let's look at what's the probability of Australia and female. So let's just see, 52 divided by 580. So 52 divided by 580, 0.089. Okay, so it's not equal. So the events are not independent. Okay, so again, incorrect. Oh, a lot of things that we need to work out in this one. Okay, so this will take you a bit longer than usual because now we need to work out another independence one. So now it's between UK and, so again, the same type of UK and female. So very similar type of question. 319, let's do 60 divided by 580 divided by 580. So this instance, 0.2466. And let's just look UK and female, UK and female. So let's check if it is the same as 143 divided by 580. 143 divided by 580. Oh, is 0.2466. Okay, so it shows us when from the table that the UK and female are independent. So option 2 was the correct one. Let's just check. So if events UK and female are independent, then the AND is equal to 0. Okay, so we showed here that is also incorrect. The AND will be 0 if something is mutually exclusive. That is when it will be 0, else it will have a value. Okay, so this was not a difficult question, but a long question, because you needed to calculate two independent calculations. If you were lucky, maybe you picked the first one that was maybe the correct one. Unfortunately, I started at the top and actually needed to work it out twice. Okay, so what one could have also done is I would have done the mutually exclusive ones first, then I would have looked at this one. So I would have probably had that, and that eliminated. And then in the exam, I need to pick between those two. So I would work out the one is, if it doesn't work out, I know the second one will be the correct one. But if you want to test it and go through both of the calculations, also fine to do that. Just remember about the timing. Okay, so on that exactly the same table, now they're asking it not in words, now they're giving us a few symbols. So now they tell us again incorrect. Which of the following statements is incorrect? So the probability of M, and they should have said it's male, is 320 over 580, and they say, well, that is going to be equal to probability of UK, okay, 319 divided by 580. Yeah, okay, so that is probably going to be correct. And if you round it off to 2 decimals, then it will be the same answer as 0.55. Okay, so if you calculate it, you will get 0.55. And yeah, you can see very close to one another. So unfortunately, not yet the incorrect one. Probability of Australia and female, Australia and female, 52 divided by 580. Then they say it's going to be equal to a probability of Australia and male. Again, very close with 50. So that is also probably going to be correct. And again, because we round it off, we will round it off both to 0.09. So even though if we look at your third and fourth decimal, it's not the same. If we round it off to 2 decimals, like in the previous one, we get that is also okay. So there wasn't really an easy one nearly that we could have eliminated or to get the incorrect one. Okay, so probability UK and male. So 176 divided by 580 gives us 0.3034. So again, if we round it off to 1 decimal, also unfortunately correct. Then probability UK, given that it's going to be male. So what's the probability that somebody is from the UK? So remember, from the UK is 319 divided by 580. Which is 0.55. Okay, but that we know that the person is male. Okay, that is quite interesting. So because the other one would have been, let me just quickly, so what we need to add to this component, so remember, if we get this, probability UK divided by given male is the probability of UK and male, even the probability of male. Okay, so when you go back to your probability functions and statements, remember when we do the given, so it will be the 176 divided by male. Okay, so it is actually 0.55. And then let's just do the same for the other question for the female component. So again, probability UK given female is probability of UK and female, 143 divided by the probability of female, which is 260, and that will give you a much higher number, probably 0.65 or 75. Oh, not that big. 0.54. Also very close to one another. So a lot of the numbers, so they could have nearly put those two also together in a question like this and this. They nearly could have done those together because they are very similar in answer as well. Okay, so again, in this one, sure, not really an easy one to eliminate. So we now nearly took 15 minutes on two questions, and there wasn't a shortcut or anything like that at all. So again, in the exam, just if there's ways that some of the other questions one can do quicker, because it might be that at 1 or 2 points you will need to sit and work out a bit more. Okay, so let's look at, I'm gonna want us to look at something a bit different. So in this one, they said, consider an experiment that you're doing, probability of E1, E2, E3, and E4. And then they ask you, but out of this 5 answers, which one of the following outcomes doesn't meet the basic requirement? So which one of these 5, A, B, C, D, and or E, does not meet the basic requirements of a probability? Okay, so which one would you guys have said is the one that is wrong and doesn't meet it? and you can just jot A, B, C, D, or E in the chat.
D.
We've got a D. Anybody else? So this question is basically looking at if you know that all the probabilities need to add up to 1. So very definition like, but one doesn't really know that it's a definition question. So let's quickly check with A, 0.35, 0.15, so it's 0.5, 0.6, it all adds to 1. 0.25, so it's 0.6, goes to 0.4, so it adds to 1. 0.25, 0.25, 0.25, 0.25, all adds to 1. 0.05, so it's 0.2, 0.45, 0.9. Okay, so that one does not add to 1, so that is definitely the incorrect one. But let's just make sure. 0.05, so that's 0.1, 0.5 also adds to 1. Okay, so I wanted to show this is because sometimes in the past they like to ask a lot of definition questions, but as we know, it's online, it's open book. You can have Excel, Google, anything open. So you nearly need to know that in a probability, all the probabilities will add to 1, and that is what they've tested in this. Okay, so we've got another few minutes. So I thought also interesting is to look at a table. So gender identity, they ask you, there's 4 different genders that we look at. There's 3 different types of feelings, and then they ask a probability around that. But just quickly, so you will see, yes, a lot of zeros. So this tells us that non-binary and low, in this instance, is mutually exclusive because the and is 0. Transgender and low is mutually exclusive because it's 0. Other and low, mutually exclusive, and then non-binary and moderate, also mutually exclusive because of the 0. They haven't asked it for us, but I wanted to show you guys how it can look in a table when 2 things are mutually exclusive. Okay, so in a table like this, that would have been needed to be 0 for it to be mutually exclusive. But when you work with variables that can be mutually exclusive, that table actually makes sense when you see it. Okay, so they're asking us work out the probability of somebody being moderate given that the person is transgender. Okay, so we need to work out what is the probability of moderate and transgender divided that the person said he is transgender. Okay, so moderate and transgender is 0.01. What's the total of transgender? Okay, that was 0. So 0.01 plus 0.04, so 0.05. So 0.01 divided by 0.05 would give us then 0.2, which is option 1. Okay, so again, when we start working with it, looks very, very easy, but important nearly to remember, okay, what is the formula? Okay, how I remember it is, and let's say it was non-binary given I. So how I always see it, if I need to work that out, is the probability of a and of the two variables, so non and I, divided by the probability of the last one, which is for I. So if I needed to work out what is the probability of other, given that somebody is moderate, it would have been other and moderate divided by the total of moderate. Okay, so again, just remember nearly how that falls into place. Okay, so just we basically did four questions on study unit, on the study unit 4. So again, I will share, and then I will set up for us on Sunday. I know it's a public holiday or it's a long weekend, but I will share with you a time slot on Sunday, probably a bit in the afternoon, say from 3 to 4 something, that we just continue. I think it's important, so I will send out a link tomorrow or on Saturday so that we can have our session on Sunday. Okay, cool. Thanks. Thanks, everyone. Let me just stop the recording.
Cheers, cheers.
Thank you, John.
Cool.